In this video, we're going to be talking about functions. In the C programming language, everything that we write takes place in a function of some kind. So far, that's always been the main function. And we pick main because in a compiled language like C, main's the only function automatically called by the compiler. So in this module, we're going to explore some other functions that we can write ourselves, like the power function or the absolute value function that we saw back in chapter 6. This will also help with our larger programs as we're getting more complex. This is the same problem-solving slide that we looked at in the magic square example, where our basic idea is to take a problem that we have and break it down into major tasks. Then we can complete smaller tasks and test them individually before we synthesize those into a larger solution. Now that we have functions, we'll be able to complete those tasks in individual functions. And functions are easy to test because we can just pass inputs to functions and observe their outputs. Functions are also great for what we call modular programming. They make main easier to understand. Main is in control of the program and the general flow of execution. So everything starts and ends in main, and main will call other functions to do tasks for it. We abstract those out of main, which makes main easier to understand. Additionally, once we've written a function, we can reuse it in a lot of different places. So if, for example, we build a function to calculate an average, we don't have to calculate an average in future programs. We can just use our average function that we created. Functions are also good for black box programming. When we say a function is a black box, it means we can't see what's inside it. We only see the inputs and the outputs. And this is a common way that large software projects are created. Each individual person on the team has a function that they have to write, but they have to match up with the inputs and the outputs that the rest of the system needs. And that way each person can be working on part of the code at the same time. So here's some general information about functions. Functions are called from main, which introduces a flow of control. Main's the only function automatically called from the compiler, so everything's going to start in main. Main can then call functions, which passes control from main to that function. Functions can also call other functions, in which case they pass control to the new function being called, sometimes called a callee or a child function. When functions end, they return control to the parent function or the caller function, so the control ultimately ends up back in main. We have something called function prototypes, which are going to provide information for how the function can be called or accessed. And these are necessary for C because it tells the compiler some information about the function as well. We'll also create something called pre and post conditions, which provide additional information for how the function can be used. And these are not required by the compiler, but they are required for understanding the function. We've seen prototypes before. Here's a quick reminder. This is the prototype for the power function, which gives us information like the return type, the name of the function, and what's called the parameter list. Parameters are pieces of information that the function needs in order to do its job. Parameters are things that we provide to the function, and so for each parameter, we'll specify its type and a name for that parameter. So all prototypes follow this same sort of format. First, the return type. The return type can be any of our basic data types, like integers, characters, floats, and doubles, or they can be void to indicate there is nothing to return from that function. And we'll see a couple of examples for void functions. There's the function name, which just like variable names, we can choose ourselves. As long as it's not a reserved word, we can use it. And our parameter list inside parentheses, where each parameter is going to be separated by a comma, and ending with our semicolon. Along with prototypes, we'll create pre and post conditions. Preconditions are things that must be met before the function is called in order for that function to work correctly. So these are basically assumptions that our function makes about its parameter list. Postconditions are things that will be met by the time the function concludes. So this is essentially what the function is going to do with the information that we provide to it and what it's going to return. So as an example, let's suppose that we're going to create a function to calculate force. Force is a very common physics calculation, and it's equal to mass times acceleration. We would build a prototype for our force calculation. So following our format, we're going to have a return type. A lot of equations in physics use real numbers, and we're going to use double because it has the higher level of precision. We're called our function forceCalc. It's a force calculation. And we'll pass to it as parameters mass and acceleration. Our precondition is that for a physics program, mass has to be non-zero and non-negative, so greater than or equal to 0. In our postcondition, what we hope to accomplish with our function is to be able to return the value of mass times acceleration. Once we have all of those pieces, we're ready to create what's called the function body. That's what we have down here. The first part looks a lot like the prototype, just without the semicolon. We replace the semicolon with the actual body, just like the body of a for loop or the body of a while loop or even the body of an if statement. We have a set of brackets, and everything in there is what our function is comprised of. We can declare new variables in functions, just like in main. So we've created this double called force. We've assigned it the value of mass times acceleration. And then we want to return the value of force because that is the reason we called the function, which is to get the value of force. All functions should terminate with a return statement, even if they're void. The return statement is how we indicate we are done executing this function, and we should return to the parent function. To accommodate functions, we're going to update our idea of the program layout. We're going to add to it a location for the prototypes and the function bodies. So after our current preprocessor directives, the includes and the defines, we're going to add our function prototypes. Then we'll have our main function, same as always. And below main, we'll have the individual function bodies for however many function prototypes that we created. Let's do an example. This program is going to demonstrate some pass-by-value functions, which is what we're currently working on. So we're going to update our layout here in our preprocessor directives. We're going to have our includes and our defines, and then our function prototypes. So this particular program is going to calculate a GPA based on the number of credit hours and the letter grade for a class. So we're going to build a function that will turn a letter grade into a numerical value for the GPA. And we're going to call that compute grade. Okay, so its job is to take a letter grade, A, B, C, D, or F, and turn it into an integer value for our calculation. So its return type is going to be integer. Its name is compute grade, comp grade. And the parameter that it needs to do that is a character called grade. Then we'll have our main function. And below main is where we'll build our actual function. So here with our function, not with the prototype, but with the function is where we'll build our pre and post conditions. So our precondition is that grade has to be a valid letter grade. A, B, C, D, or F. And our post condition, what's going to be accomplished before we return from the function, is that we're going to return an integer value that corresponds to the letter grade that we've provided. So if they don't give us a valid letter grade, we're going to return -1. That way, anybody who is reading our pre and post conditions can clearly see what our function is going to be doing, how it handles incorrect input, and what they can expect to get returned. So inside our function, we're going to do a series of comparisons to see what grade is equal to, and it should be A, B, C, D, or F, and if it's none of those, then it's invalid. We're going to return an integer value that corresponds with that letter grade. So A's are 4s, B's are 3s, C's are 2s, D's are 1, and F's are 0. And if none of those are true, then we are going to return -1. So this is kind of a creative use of the return statement. The return is the end of the function. So if grade is equal to A, we'll return 4, and this is where we will leave the function and return to main. Because whenever we hit the return statement, that's when we leave the function. If it's not A, then we'll go on and check the next set of conditionals. That way, if it's invalid, when we finally get to our else statement, our default else, this return will also take us back to main. So remember, the return is the end of the function. So now we're able to use that function in main. We're able to build the rest of the program that does the grade calculation. The calculation is going to be the total points divided by the total number of credit hours. So we'll have to ask for those values from the user. So we'll declare and initialize a couple of variables. We're going to need some character inputs, which we haven't done a lot of work with, but in this case it's very appropriate. We're going to have the letter grade, but also we're going to use answer so that they'll tell us yes or no if they want to keep entering grades. So remember, single characters use these single quotation marks. That's for a character literal. And as long as it's lowercase y or uppercase y for S, then we'll keep processing. We're going to ask them to enter their letter grade. We'll store that in my grade. And then we'll have them enter the number of credit hours for that course. And we'll store that in credit hours. Then we can use the function that we built to turn this letter grade into a point value to use for total points. Total points is going to be the credit hour times the point value for the letter grade. So we're going to call our function compute grade on their score. So when we hit our function call, control is going to pass from main to our function. We're going to give it the current value of my grade, and we're going to get back an integer that we can use in our expression. So we'll calculate the total points and the total hours. And as long as they have more grades to enter, we'll keep accumulating those values. So we're going to ask them if they have another grade, and let that be their answer, so that if it's yes and they enter Y for yes, then we'll repeat the loop. And if they enter no or anything except Y, we'll exit the loop and we'll be able to print out their final score. We'll use LF now for doubles and give them the value of total points divided by the total hours. Now, both of those are integers, so we have to be careful not to do integer division. So we're going to cast one of them to become a double, so that our final answer will be a double that we can print using this percent code. So now we're ready to test our program and make sure that it's working correctly. So we'll do, same as always, go to build and run. And remember with C, which is a compiled language, everything starts and ends in main. So when we hit run, it's going to start running right here. And C runs sequentially, so it'll execute everything in order. So right now, it's sitting at the print format and scan format function, says enter your letter grade. So we'll say that we had a 3 credit hour course and we got an A. And we'll check another one. Say we had another 3 credit hour course that we got a B in. And if those are the only 2 courses, then it'll calculate our GPA. We've got 1 class worth 3 points and 1 class worth 4 points. So the GPA total then would be 3.5 points. So our program is working correctly. Remember that when it arrives at this point in the program, at our function call, main passes control to our function here. And so we'll go from this part of main to here and run each of these segments, so from the top to when we hit the return statement. And when we return, of course, we'll return to the place where the function was called. And that's how the flow of control works for this particular program. Now what I want to draw your attention to are the parameters. Each function has its own variables, and those are called local variables. Main has local variables total points, total hours, credit hours, my grade, and answer. And those variables are only available to main. They are main's variables. So when we pass my grade to the function, we're only passing the value. The current value of my grade is what we pass along. We also have a difference between what's called formal and actual parameters. Formal parameters are the names that we use in the prototype and the function definition down here in the function body. So grade is called the formal parameter for our compute grade function. My grade, the value that we use when we call comp grade, is called the actual parameter. And what we might say is that grade, the local variable for comp grade, takes on the value of my grade from main due to this function call. So these parameters are going to line up with this parameter in the function call. So grade is equal to my grade during this call. And we have some notes to correspond with that. Here's the definitions. A formal parameter is the one listed in the function definition. It's part of the prototype. Those become the local variables available to that particular function. Actual parameters are what we call the actual values or expressions that the parent function passes to the callee. Because all this has to be is something that evaluates to a character. So we're using my grade, but it could also be anything else that corresponds to a character. So it could be a character expression, it can be a variable, anything that evaluates to a character. So here are some rules to codify everything that's necessary for a legal function call. The number of actual parameters has to equal the number of formal parameters. So in our function, since we only have one parameter in the prototype, we can only pass in one parameter in our function call, not 2 and not 0, the same number of parameters. The types of each actual parameter has to match the type of each formal parameter in order. So since this one's a character, this one has to evaluate to a character. We can't put in a float instead, it won't work. The types have to match up. Each actual parameter is associated with a corresponding formal parameter. This is more relevant if we have a function that has multiple values. So if we had a function that took in more than one parameter, we would have to make sure to put the character first and the integer second, because they're going to go in the same way they're associated. Character, then integer, character, then integer. And finally, actual parameters can be any expression if they're passed by value parameters. Every function that we're going to do in this particular module is passed by value. We'll look at something called pass by reference in our next chapter. What that means here in this function, since a pass by value function, is this could be an expression, and as long as it evaluates to an integer, it's fine. Now there's a special type of functions that are called void functions. These functions do not return any value, so we use void for the data type. And they're most common if we were to make a function that's whole job was to print something, which we do a lot so that we can get the bulk of our print statements out of main. For example, if we were computing a final grade score to a letter grade, if all we were going to do is print it, there's no reason to return a value. So instead we would have void as our return type. Print grade is the name of the function, and it takes in as a parameter, this one's the formal parameter, an integer called grade. And then based on the value of grade, we print out a specific value. Since all we're doing is printing, there's nothing to return to the parent function. So our return statement is not followed by any value. It's just return with a semicolon. In our next video, we'll explain something called menu-driven programs. And these are specific types of programs that are menu-driven. The user is presented with a variety of options, and in general, those options are implemented with functions. I'll see you then.